Okay, so today we're doing 8b.3. We are going to be applying some log rules, and we're also going to be talking about how you would graph a logarithm. There are special log rules, okay? So if you look here, if this is your problem, so right here, this is saying b to the log base b of x. Basically, whenever these numbers match, your answer becomes the x. So they're saying that equals x. Same thing here. See how these b's match? Your answer becomes the exponent y. We talked about this actually earlier today, but remember that anytime you have an answer of 1 here, it doesn't matter what your base is, it's always going to be 0. Because b, anything to the 0 power equals 1. So whenever 1 is in that spot, the answer is 0. Okay, so with these special rules, what do you think the answer is to number 1? 27. These cancel, your answer is 27. So the numbers that match are the ones that end up reducing, and your answer is just 27. Oh, also I wanted to say, there wasn't a special rule that I wrote up there, but if you had, oops, hold on, log base b of 0, the answer is actually no solution. Okay?
Why?
Because if you had an exponent of 0, you get the answer of 1, right?
Yeah.
If you have an exponent of a negative number, you end up getting a fraction. Okay? There's no way of getting an answer of 0. So that's why it's no solution. Okay, what's the answer for 2? 5. Okay, this doesn't have the log base 10, but remember this is really 10 to the log base 10 of 2. So the 10s actually match, don't they? So what is my answer? 2. Okay? This one, I don't have 2 things that match, but could I make something match?
6 squared, so then it's also 2.
Good. So log base 6 of 6 squared. So again, these cancel, and my answer is 2. Okay, example 5, I'm going to give you about 15 seconds to see if you can figure that one out.
Wait up. Is it 2x?
Your answer may have x in it.
Is it 2x? Is it x2? What?
5 to the second power is not 120.
Oh, it's 3x. That's what I was trying to say.
2x and 3x are not the same. All right, so the correct answer is 3x. So we would rewrite this as log base 5. 125 is 5 to the third power. There's already an x there, so you keep the x there. The 5's match, so those will cancel out, and my answer is 3x. Okay, what is my answer for number 6? 0. Anytime there is a 1 in that spot, your answer is 0. Okay. Again, remember that if no base is shown, the base is 10. That is your common log, okay? So if there's no base, the base is 10. So, what will be my answer for number 7? No. I've heard that right answer, but you guys say like
1.
yes, because this is really log base 10 of 10 to the first. If it doesn't say the base, it's base 10. If there isn't an exponent, we know it's a 1. Therefore, my answer here is 1. Okay, how will I rewrite example 8?
10 to the third. Isn't it log 10 over 10?
This is 10 to the third, I agree, but I don't want the 10 in the denominator. How do we change it?
You make the exponent negative.
Exponent negative. So this is really log base 10 of 10 to the negative 3, so my answer is
Wait up. Log base 10 and negative 3?
Yeah, because fraction.
So what's that?
Are we okay here?
Seriously.
Yes? Okay. There is now a new number in math. It's actually not new. You've just never heard it before today.
Is it pi?
You were talking about it like in a
Hold on.
building.
Shh. I cannot hear a question when other people are yelling out. Marcus, you have the floor. What is that?
On number 8, can't you write it 0, 0, 1?
You could, but again, you want to change it to an exponent with like a regular base. So if you did that, you would still end up with 10 to the negative 3 because you would want to change it to base 10. Okay? All right, so this new number is called e. It is similar to pi in that it is an irrational number. Irrational means goes on forever, okay? And it does not repeat, okay? So we know that the approximate for pi is 3.14. The approximate for e is 2.718. Okay. If base e is used, it is called a natural log, okay? And instead of writing a log, we write ln. That means natural log. Why they didn't write it as NL, I have no idea, but this is the way it's written, and you say it as natural log, okay? So if you have a natural log, it is base e, okay? So you know how regular logs are base 10? Natural logs are base e, okay? And then you could change it to exponent form by writing e to the x equals y. Okay, so on number 9 and 10, all they want us to do is rewrite these in exponent form. So, and you know what I want you to do is just leave it in terms of pi and leave it in terms of e. You don't have to worry about the numbers right now. But, so how would you end up rewriting number 9 in exponent form? Yes, 31.01 is correct. That's it. That's all you have to do is just write it in exponential form. So, like I told you, natural log is always going to be what base? E. It will always be base E. It can never be anything other than base E. Natural log always is base E.
Wait, why did you say n?
Yes. E to the third equals, and actually this was a typo, it should be 20.09. And again, if you were to check this on your calculator, it is approximately 20.09. Pi to the third is approximately 31.01.
Why did you
Yes.
say in?
It's not, it's an LN. It looks like IN.
Natural log.
Good job, Sarah. Somebody's listening.
Backwards?
You weren't listening to anything I said. I said, I don't know why they didn't do it NL instead of LN, but that's just the way it is, and it's natural log. Okay.
Is there a typo on number 11?
Is there a typo on number 11? No. No. Okay. To graph a log equation, the first thing you want to do is rewrite it in exponential form. So let's look at number 11. Please stop. And let's write it in exponential form. Oftentimes when we had a log, we would have the log like this, and then we would put equals x. So this time they have equals y. It's on the opposite side. If you want to write it this way, if that's easier for you to look at, you can. Okay, the equal sign can be on either side of your equation. So if I rewrite this in exponential form, what would it be? 3 to the y power equals x. Now, this is why there are y values here. Whatever is your exponent, that's the value you want to choose the numbers for. Okay? Good. So that means x is going to be 9 when we plug in 2. When I plug in 1 for y, 3 to the first is 3.
1.
Very good. Anything to the 0 is 1. Good. 1 over 3 and 1 over 9. Very good. Okay, so now we're going to graph these. So over 9 up to 1, 2, 3, 4, 5, 6, 7, 8, 9 up 2. So 9's at the very end and then up 2. Over 3 up 1. This is 9 down here. Over 1 up 0. And then we have over 1/3 negative 1. Over 1/9 down 2. What? Okay, so 1/3 on the x is in between the 0 and the 1, and then I'm going down to negative 1. 1/9 again is in between 0 and 1, I'm going down negative 2. What do you notice? Do you think this graph is ever going to hit the y-axis? No. What does this remind you of? Your exponential, except for they are sideways. They've kind of rotated, haven't they? Where do you think the other one would be graphed?
On the other side.
We'll have to wait and see.
Real numbers? Would that be on the other side? The E.
Oh, that's a good question, but I don't know. What?
So we're just going on and on and on.
Yes, so this will keep going on and on and on. So which values are going to get you closest to the y-axis on this one? Your negative numbers, right? Negative y values will get you closest to the y-axis. All right, number 12. Okay, make tables and graph y equals 2 to the x and y equals log base 2 of x on the same grid. So you might want to get two different colors out so you can kind of see the difference. So I'm going to do this one first. Notice it's already in exponent form. Since the exponent is x, that's fine. Since the exponent is x, I'm choosing values for x. If my exponent is y, then I choose values for y. Thank you. Okay, so 2 to the second power is 4. 2 to the first power is 2. 2 to the 0 is 1. 2 to the negative 1 is
Negative 1 over 2.
not negative, just 1/2. And 2 to the negative 2 is 1 over 4. Okay? So now we're going to graph this one. You should already have an idea of what this one looks like because we practiced it a lot in 8A, and you can look at the word wall and know where it might be. But we go over 2, up 1, 2, 3, 4. Over 1, up 2. And then we have 0, up 1. And then we have negative 1 is at 1/2. Negative 2 is at 1/4. Will this graph ever touch the x-axis? No, it will not. It'll get closer and closer. And which values will get me closest to the x-axis? Negative x values. Very good.
I'm not sure.
You're not sure what?
Because I grabbed the other one too, and I'm not sure if that's right.
Okay. So what's the first thing we have to do on our log equation in order to be able to graph it?
Put it in exponential.
Put it in exponential form. So again, if we want to, we can rewrite this as log base 2 of x equals y. And what would my exponential equation, how would I rewrite it?
Make sure you do the y power.
2 to the y power equals x. So notice that we've chosen y values because y is in my exponent. So let's see what you do. Go ahead. I'm going to let you guys try this one on your own. Yes.
Yeah, it's the same thing.
Oh.
Isn't it the same?
It's the same thing.
No.
Are you positive?
No, because it's over.
It looks like the same thing.
Look, 1, 2, 3, 4, up
Oh, it's backwards.
over 2, up 2,
Yes.
over 1, up 2.
They switch sides.
Yes, they ended up switching. Okay, because we plugged 2 in for y. 2 squared is 4. 2 to the first is 2. 2 to the 0 is 1. 2 to the negative 1 is 1/2. 2 to the negative 2 is 1/4. When you graph this, we're going 4 on the x. 1, 2, 3, 4. 2 on the y. 2 on the x, 1 on the y. 1 on the x, 0 on the y. 1/2 on the x, negative 1. 1/4, negative 2. Bless you. Okay, so now when we connect our dots,
Oh, okay.
it's going like this. Okay, what would you say about these two graphs?
They're opposite.
They're not opposite. It starts with an S.
Symmetrical.
They're symmetrical. Okay? There's a line of symmetry basically in here, you know, and they are symmetrical to each other. Okay. Do we have any questions?